Okay. Good morning, everyone. We are going to start our today's lecture. Okay. So, in last lecture, we saw the what is meant by gas power plant. Okay, what is the gas turbine, and what are the schematics or the general layout of gas turbine power plant. It is having three main components, that is the inlet system, compressor, combustor, and the turbine. Okay. So now what are the advantages why we are going to we use the gas power plant? Those are some advantages. First one is that great power to weight ratio compared to the reciprocating engine. If you compare this gas engine with the reciprocating engine or gas power plant to the reciprocating power plant, you will see the power to weight ratio very high. Means it will produce more power than the IC engine whenever we kept a constant weight. Second, smaller than the reciprocating counterpart of the same power. It is the size for the same capacity is very small whenever we compare it to the IC engine, and the lower emission levels. Its emission coming out from this particular power plant is low when we compare it to the IC engine. Now, why is that? Because the combustion which is carried out inside the combustion chamber, that combustion is totally full combustion will be takes place. Means there will be very less amount of unburned hydrocarbons are present in the exhaust gases. Okay, and the air availability, also the oxygen available for the combustion is sufficient. So the total or full combustion will take place, complete combustion will take place, and because of that, the emissions are lower in this type of turbines. Okay, now disadvantages are it is a very expensive. Okay, so this particular power plant is very expensive, particularly gas turbine, because it will contain different parts which is having constantly having very high temperature. So we have to manufacture those parts using special materials, considering its mechanical properties, thermal properties, etc. Also, the speed is very high, so we have to consider these particular points, that is high speed and high operating temperature. And because of that, we have to use special material. Particularly, we have to analyze and design it very well so it will work efficiently. So again, that is another task, that is designing and manufacturing of the gas turbine is very tough problem. Okay, material standpoints, it is very tough to select the material because continuously the temperature inside the combustion chamber or inside the turbine also it is very high. Okay, so next, tend to use more fuel when they are idling. So when there is no any load on the turbine, in that case it will consume more fuel. Okay, they prefer a constant rather than the fluctuating load. Now this is very important because whenever we considering the gas turbine power plant or whenever we considering gas turbine instead of the IC engine turbine, because IC engine power plant, there is some one particular factor. That's why we are using the gas turbine when for the power generation. And if you want to use it inside the vehicle for the moving of the vehicle, we have to use the IC engine because whenever we saw efficiency versus load curve, okay, efficiency versus load curve for the gas turbine also and for the IC engine also, because both are the same. Both will provide you the mechanical power at outlet. Okay, but in vehicle we are using internal combustion engine rather than the gas turbine engine because the overall efficiency, the maximum efficiency of that particular gas turbine power plant or the any particular gas turbine is very high. Okay, it is nearly 90, 80 to 90%. Okay, but when we achieve this particular efficiency when it is running on the designed load. Okay, whenever we design in a particular IC engine or a gas turbine power plant or the gas turbine, we have to consider some load. Okay, and for that load, we are going to design that particular turbine. Now, when that turbine is working or working on that particular load, when that load is working on that particular gas turbine, then it will give you the highest efficiency, that is nearly 80 to 90%. Okay, but slightly uh, fluctuating from that design load. If you fluctuated from the design load, its efficiency will be sharply decreased. Okay, similarly, if we increase a small amount of load on that particular gas turbine power plant, its efficiency will sharply decreases. Okay, so that's why we are not using this one in our vehicles, because we know on vehicle always the load is going to be fluctuating. Okay, uh, the IC engine does not uh, having that much of variation of efficiency if you see with respect to load. Considering the efficiency of IC engine is less, okay, whenever we compare to the gas turbine power plant or the gas turbine, it is having nearly 35%, maximum 35% we have achieved. So at the design load, it will give the maximum efficiency definitely. But whenever that load is varying, it does not vary, that efficiency does not vary that much. Okay, so because of this, whenever there is any fluctuating load, the IC engine gives a proper efficiency, and that's why we are using the IC engine in vehicle rather than the gas turbine. Okay, and the gas turbine is specifically used for the power generation because in power generation, as we know, the load is not going to be fluctuate. Okay, we are constantly making constant. The load will be the constant over the time, and because of that, we will achieve the maximum efficiency for that particular period. So whenever there is any no load or there is a fluctuation in load, the efficiency of gas turbine is reduces drastically, and because of that, we are not using the gas turbine in the vehicles, particularly in the vehicles. Okay, so these are the some disadvantages of the gas turbine power plant related to the gas turbine. Now, what are the different sectors are there, or what are the different companies, institutes are generating this particular power? Now, there are many private sectors or the private industries are there which is using a gas turbine power plant. Also, there are some public sector units also. Okay, like the NTPC, NHPC, etc. These are the PSUs, right? We already see those details of NTPC and NHPC. There is also uh, owns the gas turbine power plants. Okay, then Tata, some private players like the Tata Powers, Reliance Power, they will also they have also installed this gas turbine power plant. Okay, why they are using the mostly gas turbine power plant? Because the the land requirement or the capital investment is very less when we compare it to the thermal power plant or the nuclear power plant or the hydroelectric power plant. Okay, it will require very small amount of land. The size of that particular power plant is very small, and that's why we are mostly these private players or the private companies are using the gas turbine power plant to generate the power. Okay, this like the Adani Powers, Damodar Valley Corporation, Nalco Infratech, SJVN. Okay, these are some of the private companies which will use this or the which will generate the electricity or the power by using the gas turbine power plant. These are the another different sectors, private sectors. Okay. Now, particularly we are going to see the what are the different gas turbine power plants are there in particularly in India. Okay. So similarly, by using the previous map, yesterday's map, you can also find out the diesel powered power plant and also the gas power plants. Okay, these are the natural gas power plants. Okay, here we are using the natural gas. We are using the natural gas as a fuel. Okay, and there these are the different power plants which are situated around the India. Okay, near to the in Gujarat Valley, you can see there are large numbers of gas power plants which are running on the natural gas. Okay, so you can also select this one. You will understand. You will get the information. What is this installation capacity and the location? Okay, so in near to this Raigad, there is a Uran gas turbine power plant which is having 432 megawatt of installation capacity. Similarly, there are three different uh, uh, three different power plants has been installed in Maharashtra. Then in Goa also there is one, that is the Salgaonkar compressor gas sorry gas turbine power plant that is having the installation capacity 48 megawatt. Okay, so these are the gas turbine power plants which are situated in the India. Also, you can see the diesel power plant. Okay, these are the particularly based on the IC engines. Okay, you can see diesel power plants, one in the Lakshadweep, one in the two are in the Andaman Nicobar. Okay, where we using the IC engine to run this particular power plant. Also, you will see the petroleums and natural gas which is available in India. That also you can see oil and gas wells, refineries, then the natural gas pipelines are there. Okay, these are the main natural gas power pipelines you will see. Okay, which will connecting the main particular cities uh, of India. Okay, also the petroleum products pipelines are there. Okay, so these natural gas are generally used in gas turbine power plants. Okay, uh, you will see this particular one. Okay, so that is regarding the gas power plants. These are the gas based power plants which are under running under the NTPC. Okay, National Thermal Power Corporation. You will see the Anta, Oria, Kavas, Dadri, Janurgagar, Rajiv Gandhi CCPP, then Faridabad, which is having the gas power based power turbine. Okay, power station, and their capacity is given here. So in gas turbine power plants, we are generally using natural gas, compressed natural gas as the LNG, liquefied natural gas. Those are used as a fuel, okay, instead of coal. The main advantages of that, it is having less pollution whenever we compare it to the coal. Okay, pollution impact or the environmental impact is very less. The size is compact. Compact size is it is having compact size, and also the capital installment or the capital investment is very less when we compare it to the thermal power plant. Okay, so because of that, these particular type of the power plants are generally used for the as a peak load power plant. Okay, peak load power plants. Okay, now what is peak load power plant means? Consider there is a constant requirement of 300 megawatt. Okay, for 1 or 2 hours for all over the day, but in night, during the night or during the evening, we require 2 megawatt extra power. Okay, so in that case, we can start or we can running this particular power plant for that particular evening only. Okay, or for the 3 or 4 hours, and you will get this extra 2 megawatt of energy. So this is used, particularly used as a peak peak load type of power plant. Okay, now, next one is the important is to combined cycle power plant. Now, combined cycle power plant means what? We are just going to combine the gas turbine power plant with the thermal power plant. Means, first of all, we are using gas turbine power plant. Okay, in gas turbine power plant, there is a compressor. After compressor, there is a combustion chamber, and then the turbine is there, right? So whatever the air coming into the compressor, it will compress the air. It will flow into the combustion chamber, where the combustion will take place, and after that, it will send it to the turbine. In turbine, expansion will take place. Now, after expansion, when that flue gases, exhaust gases coming out from the turbine, it's also having very high energy. It will contain very high energy because its temperature is nearly 300 or 200 degrees centigrade. So whenever we reject these flue gases directly to the environment, all this particular thermal energy which is contained by this by exhaust gases is going to be waste. So to recover this particular thermal energy or the heat which is available in the exhaust gases, we are passing these exhaust gases through the boiler. Okay, or we can say the one heat exchanger, where the heat of or whatever the waste is of this particular exhaust gases, it has been given to the water. Okay, and because of this heat, water will get evaporates, and this steam which is generated, high pressure high temperature steam, it is again passed through the hydraulic sorry the turbine, steam turbine. Okay, and here we get the extra power. Okay, so whatever the heat going out waste to the atmosphere, that heat will be recovered in the form of in the thermal power plant. Okay, so when we combine these two power plants, it is called as a combined cycle power plant or the combined cycle thermal power plant. Okay, I will show you one video regarding this, so you will get understand the idea behind it, what is meant by combined cycle power plant. Okay. Just see if the video audio is audible or not. Is it audible or not? Video is audible, right? Can you please reply? Okay, I think it is audible. Just okay.
A combined cycle gas turbine power plant generates electricity using heat released during the combustion of natural gas. This type of power plant has two types of turbines, a combustion turbine and a steam turbine, both connected to a generator. With the same volume of fuel, these two turbines generate more electricity when they are used together. In some power plants, each turbine is connected to its own generator. In the combustion turbine, air is injected into a compressor at high pressure. The compressed air then travels to the combustion chamber, where it mixes with the fuel. This air-gas mix ignites and produces exhaust gases that turn the combustion turbine. This turbine drives the generator. The heat of the gases released by the combustion turbine is recovered in a boiler lined with pipes in which water circulates. This water is heated and travels to a tank where it turns into steam. The steam is channeled towards the steam turbine and makes it turn. The energy produced by the rotation of this second turbine is transmitted to the generator, supplementing the energy already transmitted by the combustion turbine. In the generator, the interaction between the electromagnets of the moving rotor and the copper coils of the stationary stator produces an electric current. Transformers boost the current's voltage to between 225,000 and 400,000 volts, thereby facilitating transmission over the grid's high voltage power lines. The steam travels out of the turbine into a condenser in which cold water is circulating. The steam is turned back into water so it can be returned to the boiler. The fumes produced during the combustion process are filtered before being discharged through vent stacks. As natural gas is used as a fuel source, the power plant emits half as much CO2 as a coal-fired power plant. Combined cycle plants are flexible, responsive and more efficient than conventional fossil-fired power plants. Capable of reaching full power in less than an hour, they are used, depending on the country, continuously or during peak periods and very cold spells, for example.
So these are the combined cycle power plant. Okay, so we are using this gas turbine power plant generally as a peak load type of power plants. To achieve the peak load, we are using the gas turbine power plant. When we combine it to the steam turbine power plant or the thermal power plant, it is called as the combined cycle power plant. Okay, whatever the waste heat going to be rejected from the gas turbine power plant, it is recovered inside the by using the thermal power plant. Okay, now next power plant we are going to see, that is nuclear power plant. Okay, these are the regarding the gas turbine power plant. The next point we are going to see, it is a nuclear power plant. Just a minute. So nuclear power plant that we are going to see, this is the another power plant through which we are producing the power. In India, there are many nuclear power plants we already installed, and it is working on the nuclear energy of the atom. Okay. Now, first of all, what is the fuel? Fuel we are using in the nuclear power plant, because if you saw, the nuclear power plant is working on the same thermal cycle. Okay. Whatever we are using in thermal power plant, the same cycle is present. We are generating the steam, and that steam will be passing through the turbine, and it will produce the power. But the fuel we are consuming inside the nuclear power plant is not a coal, it is not a gas, or it is not any particular diesel or anything else. Okay, it is the nuclear fuel that we are going to use. So for that, you must know what is meant by atom, what is the molecule, what are the different subparticles of the atom. So whenever we consider the atom is made up of three subparticles. First of proton, second one is the neutron, and third one is the electron. Okay, proton which is having the positive electric charge, electron will having negative electric charge, and neutron is a neutral charge. Okay, it doesn't contain any charge. So whenever we consider any particular fuel, atom as a fuel, there are two possibilities. We can find out or the carry out, extract the power in the terms, or the extract the energy in the by using the chemical processes or the nuclear processes. Chemical processes is a different one. Okay, in that case, there will be no any that nuclei of that particular atom. It does not going to be affect, or we are not uh, uh, not what you call as class, divide the nuclei in the case of chemical reaction. But in nuclear reaction, what we are going to do, we are going to split up this particular atom. Okay, we are going to split up this atom. We can combine two atoms into the one, or we are split up one particular big atom into the two small atoms. Okay, that will happen in the nuclear reaction or the nuclear power plant. Okay, so there are two types of nuclear processes are there, or nuclear reactions are there. First one is the fusion, and second one is the fission. Okay. Now, what is meant by fusion? Fusion, as name as this particular word indicates, fusion means what? We are fused the two lighter weight atoms into the one atom. Okay, we are just fusing that two particular atoms into the one atom and producing the high weight or the higher weight or heavy weight one single atom. So joining two or more lighter atoms to the one larger atom, that is known as the fusion process. Okay. And second one is the fission process. So in fission process, just opposite of the fusion. Okay. Here we subtract or the divide the large atom into the two small atoms. Okay. So that is the main difference between fission and fusion. Okay. Now the fusion process, it is carried out inside the star. Okay, generally, if you saw naturally, this fusion process will be carried out in the big stars like the sun. Okay, in sun, what will happen? Two hydrogen atoms are fused together, and one helium atom will be generated. Now, where from where this energy is coming? The energy is coming from the differences of the mass. Okay, whenever we fuse these two different elements, okay, and producing the one single element, if we consider this one is having one mass, one AMU mass, atomic mass unit, and it is having one AMU mass. Okay, when it combines, you must be produce the particular atom which is having mass 2 AMU, right? But in this case, we cannot produce the produced helium or whatever the component is there, it is having less than 2 AMU mass. Okay, it is nearly 1.998 something. Okay, so the difference between these two, that is 0.02002 something kg or AMU, that mass has been converted into the power. Okay, that whole mass will be converted into the power, and you can find out this mass by using the uh, one of the very popular equation of the Einstein, that is E is equal to mc square, where E means energy generated, m means mass, and c means light speed of light in vacuum. Okay, so by using this particular equation, you can find out how much energy will be generated when we completely uh, consume that much of mass. Okay, so in the fusion, that difference between these two masses, product and the process, first of all, the raw material, that is converted into the energy. Similarly, in the fission reaction, okay, whenever there is one neutron which is going to strike on the very radioactive nuclei or the atom, it will split up into the two lighter atoms. And whenever we considering its mass, consider it will having the mass 2. So the masses of these particular products are less than 1 1. Okay, if you consider this, it is having mass of zero point 0.9, it is having mass of zero point 0.9. So whatever the remaining mass is there, whenever we apply the mass conservation formula, you will see there is a 0.2 AMU mass has been reduced. Okay, so this mass has been converted into the energy. Again, you can use this Einstein's energy equation to calculate the power generated or the energy generated. Okay, so that's how the fission and fusion works. So generally, we can in the nuclear power plant which are present in the earth, we are using fission reaction. Okay, we are using fission reaction inside the nuclear power plant, not a fusion reaction. Okay, fusion reaction in fusion reaction we are using the high weight molecule, and we split up that molecule into the two lighter molecules. Okay, so the first requirement for this particular fuel, that atoms or whatever the fuel we are using, that must be unstable. Okay, so whenever we strike through the neutron on that particular atom, it will split into the two lighter atoms. In fusion, we cannot until now we are not able to find out or not able to carry out this fusion process on Earth, because to start this fusion process, to fuse these two particular atoms, we require very high amount of energy. Okay, and this amount of energy is only possible to get from this fusion reaction. Okay, so to starting or to fuse these two atoms into the one single atom, it is very difficult to fuse those atoms without uh, without uh, uh, without any high energy, and this energy is very difficult to achieve this particular energy. Okay, but in stars, what will happen? The gravitational force of that particular star will fuse these two atoms. Okay, the gravitational force is that very high in the stars, and because of that, what will happen? These two atoms will fuse together under that particular gravitational force, and because of that, the in stars there is a fusion process will happen. Okay, generally we are using the fusion process. This is as we discussed earlier. Okay, whatever the difference between these two mass differences, that has been converted into the energy. Okay, similarly in fusion process, one neutron which is slow neutrons which is strikes on the uranium 235, and that uranium 235 will be converted into the rubium and cesium, which is having the different mass numbers. Okay, and three neutrons will be coming out from this particular process. Now these three neutrons again going to strike another U235 atom. Okay, so that's how the chain reaction will start, and because of that, the addition of energy which is generated in very small time, it will give you the higher amount of energy. Okay, similarly in the nuclear bomb also there is the same process were carried out. But in nuclear bomb and in nuclear reactor, the difference is that in nuclear bomb, the chain reaction is not in under control. Okay, it is not in control in case of the nuclear bomb. In the case of nuclear reactor, we are going to control this reaction. Okay, by using the different instruments. That also we are going to see. So this is a fission reaction where we split up this particular uranium 235 atom into the lighter weight atoms. Okay, it will produce as the excess amount of energy. Now to control this reaction, okay, because if there is a fuel available and this chain reaction will start, it will not in control. Okay, so for controlling this reaction, we are going to control these neutrons. Okay, if those neutrons are going to strike on the another atom of uranium, it will again split up into the three different atoms, and again three neutrons will be given up. Those neutrons again going to strike another atom. So that to stop that particular chain reaction, we are using the control rods. Okay, inside the nuclear reactor. Okay, we are using control rods. Also, we are going the moderation medium and cooling medium to control this particular chain reaction. Okay, so that details about that we are going to see in the next lecture. Okay, before that, just you see the schematic of the nuclear power plant. Okay, in nuclear power plant, this is the main core reactor is there. Okay, core of the reactor will be there. Here, these are the fuel rods. You can see the in the red color, that is the fuel rods. Okay, these in the black color, those are the control rods. Okay, and around it you will see the water. Okay, this water will be work as a moderator as well as the cooling medium. Okay, and this water will heat up, then it will travel from the pipelines. Okay, it will travel through one heat exchanger. Okay, here also that is the water is there. Generally this water is called as a heavy water, which is came in contact with the connect these fuel rods. Okay, or whatever the water present inside the nuclear core, it is known as the heavy water. Now this heavy water will pass through this one heat exchanger, and whatever the heat absorbed from this nuclear reaction, that heat will be transferred to the another uh, cycle of the water. Okay, and this water which is coming in contact with this or heat will be exchanged from the heavy water to the normal water, and that normal water will convert it into the steam, and that steam is again going to be transferred through the steam turbine. Okay, and that's how we will get the energy. The power generation part, or whatever the cycle where the power actually generated, it is similar to the thermal power plant, but the heating or what how we are achieving that particular steam, it is the different in case of nuclear power plant. Here we are using the nuclear fuel and the nuclear chain reaction. Okay, so details regarding this we are going to see in the next lecture. These are the basics. Okay, and there are different types of nuclear power plants are there. What are the control rod and how they control the particular chain reaction, that we are going to see in the next lecture. Okay, so we will stop here. If anybody have any doubt, you can ask now.